use the derivative formula f prime of a equals limit as h goes to 0 of f of a plus h minus f of a divided by h to find the derivative of f of x equals 4x cubed minus 10x, where a equals 1. The first thing to do is write down the derivative formula for a as a 1. So f prime of 1 equals limit as h goes to 0 of f of 1 plus h minus f of 1 all divided by h. And that'll give us limit as h goes to 0 of, next thing to do is evaluate f of 1 plus h. That means to take f and replace all the x's with 1 plus h. So that will give us 4 times 1 plus h cubed minus 10 times 1 plus h. And then we're going to subtract from that f of 1, which means to take f of x and put a 1 in for every x. I need to subtract this quantity since there's multiple terms. I'm going to put this into brackets so that we be sure to subtract every term. It's really important that you do that. Divided by h. Now this will be the 0 over 0 indeterminate form, and it will continue to be until we can factor an h out of the numerator to cancel with that h in the denominator. That's always our goal. To be able to factor the numerator, we have to have a single expression of terms adding and subtracting each other. We're going to need to expand out that 1 plus h quantity cubed, as well as distribute in the negative 10 and the 4 that's with the 1 plus h cubed. So I'm going to write the 1 plus h cubed as 1 plus h times 1 plus h times 1 plus h. I'm going to distribute the negative 10 times the 1 will be negative 10 times an h will be a negative 10h. And then we'll start to evaluate the number in the bracket. So 4 times 1 cubed is a 4. Negative 10 times 1 is a negative 10. All of this is divided by h. So we will have limit as h goes to 0 of, now to cube 1 plus h. We're going to pair off 2 of them. I'll take the second one and third one and FOIL those out. First, 1 times 1 is 1. Outside 1 times h is h. Inside 1 times h is also h, so we will have a 2h when those add together. And then last is h times h, which is h squared. We have a minus 10, a minus 10h, and then minus in the brackets will be a negative 6 all over h. So we will have limit as h goes to 0 of 4 times. Now the next thing we're going to do is FOIL out 1 plus h, 2 terms, times 1 plus 2h plus h squared, 3 terms. 2 terms times 3 terms will give us 6 terms. To generate the 6 terms, you can take the 1 and one at a time multiply it by each of those and add all those together. 1 times 1 is 1. 1 times 2h is 2h. 1 times h squared is h squared. And then take this second term and multiply it times each of these. Add those together. H times 1 is h. H times a 2h is a 2h squared. H times an h squared is an h cubed. The 4 will distribute that entire quantity. And then we have a negative 10, a negative 10h, and a positive 6. Subtracting a negative 6 is equivalent to adding a 6. All that's divided by h. So we'll have the limit as h goes to 0 Let's distribute the 4 in. 4 plus 8h plus 4h squared plus 4h plus 8h squared plus 4h cubed. We have the minus 10, the minus 10h, and the plus 6. All this is over h. Now let's combine together like terms. One thing that should happen at this point is any terms that do not have an h, which are just going to be constants, should all fully cancel. And I see I have a positive 4, a negative 10, which will add to be a negative 6, plus a 6, and those do fully cancel. Now I have 3 terms that have an h. I have 8h, I have a 4h, and I have a negative 10h. 8 plus 4 is 12, minus 10 is 2h. I have 2 terms that have h squared, 4h squared and 8h squared. 4 plus 8 is 12, plus 12h squared. And I have 1 h cubed term plus 4h cubed. All of this is divided by h. We still have the 0 over 0 indeterminate form, but we have an h in every term that can factor, and that's always our goal. I will factor an h out, leaving me with a 2 plus a 12h plus a 4h squared. All divided by h. The h's can cancel. We no longer have the 0 over 0 indeterminate form. We can now plug a 0 in for any remaining h's. And so f prime of 1 will equal 2 plus 0 plus 0, which is going to give us a 2. This represents the derivative of the f of x evaluated at 1.